Hey guys, Mr. Jenkins here again. I noticed in the first video that my camera wasn't very centered on my beautiful UK wall, so I tried to fix that for this video. So that'll be there for your viewing pleasure in the other window. So enjoy. This is the video for lesson 2.2, which is about direct variation. Just a side note before I get started. This will not be directly tested, but it will help as a supporting skill for other things we do, and also something that we cover later in the year. So that's why we are going to cover it. So with that, I'll go ahead and get started on your notes. Should be pretty quick. All right, as I said, this is lesson 2.2, and the title of the lesson is direct variation. So we're going to learn what that is. As you can see, it's one of your vocab words. It's also I wanted to go over your learning target, which is after this lesson, we will be able to write and interpret direct variation equations. So example 1 is we want to learn how to identify direct variation from a table. So the directions for each function determine whether y varies directly with x. If so, what are the constant of variation? And then write the rule. So basically all direct variation is a proportional line. You may or may not remember this, but a line that goes through the origin or 0, 0 is a proportional line. So that's kind of what we're thinking about graphically. So the formula we want to kind of use is the constant of variation is called k, and that equals y divided by x. If we're doing regular slope, we have to do y2 minus y1 over x2 minus x1. So that's previewing something, but for this, we just take y over x. So you're not finding slope here, but it is very similar to a slope. Okay, so what we want to check, like on A, is we want to do negative 21 over 3. And we want to see, is that the same thing as negative 14 over 2? And then is that the same thing as negative 7 over 1? The answer here is yes, because, well, if we divide them all out, we get negative 7 for all of them. So this is a yes. So it says, if so, what's the constant of variation? So I would say k equals negative 7. And then it also wants the equation. So the equation of a proportional line is y equals mx. The equation for this type of line, well, you can also use y equals kx because the constant of variation acts as our slope. So we would just say y equals negative 7 times x. So just so you know, you can always double check your rule. So if I plug in the input values, does it get me to the corresponding output values? So if I plug in 3 for x, it goes to negative 21. If I plug in 1 for x, I get negative 7. So that's how you can kind of double check your work. Looking at example B, 5 over 2, is that the same thing as 7 over 3? The answer here is no. You could check that with division, but hopefully that's pretty obviously a no. So we don't need to go any further. So we just say no, and then there's nothing else really to it. Now this is a good example of one where you would have to be careful, because if you're finding slope, I think it is actually linear. So just be careful. Like if I do, rise over run here, that'd be 2 over 1. 7 minus 5 is 2, 3 minus 2 is 1, and then 13 minus 7 is 6, and 6 minus 3 is 2. So actually, okay, so it looks like it's not linear. I thought it might be linear, so disregard that. But anyways, the point still stands. It's y over x. You're not finding slope, okay? Just be careful there. Looking at example 2, we want to identify direct variation from an equation. These are pretty easy if you know what you're looking for. The first thing you want to do is solve for y on this, if it's not already done. Because if it is direct variation, we have to do the same thing we did last time. What is the constant of variation? Well, we don't have to write the equation here because we'll already have it. All right, so how do we solve for y on example A? We need to divide everything by -3, giving me y equals, sorry, we divided by -3, -8/3 x. Okay, so in this example, this would be it would be direct variation, and I know that because there is no constant. So I'm going to say yes, and just so you know, the reason I know is because there is no constant. Or you could say because the equation is in the form y equals k times x. All right, so what's k? K is your coefficient of x. So k equals -8/3. All right, next example, solve for y. That means divide everything by 7 in this case, which is going to give me y equals 3/7 times x minus 28/7 is -4. All right, so the answer here, because of this last term, is no. Okay, if there's a constant, it is not direct variation. Is it linear? Yes, because it's y equals mx plus b, but it's not direct variation. It's not a line that goes through 0, 0. Thinking ahead to next lesson, you might ask yourself, can I tell where it passes through or what's the y-intercept? But that's just a preview to the next lesson. I'm going to leave these other A and B for you to do and check on your own. Okay. Example 3, we're actually going to find a missing variable, and it says we're going to use proportions. So that's the easiest way to do this. It's not the only way to do it, but I think it's the easiest way. So it says suppose y varies directly with x. So they're giving us that as a fact. Then it wants to know what is y when x equals 12. So we're gonna say, just always remember y over x. That's how you want to set things up, your ratios. So with these two, we would go 15/3. You don't really want to simplify that. That's not going to do you any good for the next one. You want to leave it as a fraction, and then we want to set it equal to, it says what is y, so we don't know y, when x equals 12. Okay? And now remember how to solve this. The easiest way to solve this one is say, we can see that 3 times 4 equals 12. So 15 times 4 equals y, and 15 times 4 is 60. Or if you don't see that, remember that you can always use cross products. So you can use cross products to get the equation 3y equals whatever 15 times 12 is. Sorry, I did that. Let's see. I think that says 15. On my notes, it says -15. So on the filled out notes, this is going to be a little bit different. But I think this says +15 here, so I'm just going to solve it as is. Anyways, if we want to solve this as a proportion, 15 times 12 is 180, and then 180 divided by 3 is going to give me that. Okay. Move it on to the next one. I'm going to leave that one for you all. And then example 4, just a word problem, but it's going to be very similar to what we just did. It says the salesperson's commission varies directly with his sales. For 1,000 in sales, the commission is 85. So I guess going back to last lesson, which one was my input X, which one was my output Y? So in this case, your commission depends on your sales. So we would say that this is going to be X, this is going to be Y. That's not super important here because if you set it up backwards, all you have to do is set the other one up backwards, but just good to review those, which one's input, which one's output kind of problems. Anyways, solve this just like we did the last one. So we're going to say 85 is to 1,000 as, so now we're looking for the commission. So we're looking for an output and then for an input of 2,300. So this one, you're not going to want to probably use mental math on because 1,000 times 2.3 is 2,300. So 2.3 is not very nice. So I would just say cross products there. So 85 times 2,300. Is 195,500. And then divide that by 1,000. Because we have 1,000 Y on our other cross product. So when we do, we get Y equals 195.50. 195.50. I was just looking at my notes. I actually solved this a different way on my notes. So what I did is 85 divided by 1,000, get a decimal, and then multiply that decimal by 2,300. You get the same answer. I really don't care which method you use. Use whichever one makes sense. And you can try B on your own and check it. Our last example is to graph one of these guys. So example A and B are already kind of graphed up there. I think the biggest thing to remember for these is that our y-intercept, remember we kind of call that B, is always 0 on this lesson. Okay, that's what makes it direct variation. So if I'm looking at example A, I know I'm going to start at 0, 0. Sorry, the graph is so small. And then I'm going to use my slope from there, which is the same thing as K. So remember, rise over run, so that can mean down 2, right, 1, 2, 3. Or it could mean up 2, left, 1, 2, 3. Okay, and then you have your shape for your line. Just draw a line. I can erase it. All right. So then just draw your straight through, put arrowheads on both sides, and that's it. All right, so that will conclude our notes. Remember that you can watch this today at home, so you have it finished for class time. That would give you longer to work on the notes, but that is totally optional. It's up to you. So I would just continue to encourage you all to speak up if you're having any issues. We should have lots of time to do stuff like homework help and whatnot in class if you're having any trouble. So yeah, just let me know. Thanks. Have a nice day.